Hi, we are discussing about linear phase filters. In the case of a linear phase filter, the phase response must be proportional to frequency. Okay, here we remove the proportionality by a proportionality constant alpha. We can say that the phase response theta of omega equal to plus or minus alpha omega plus beta, where alpha is the proportionality constant, and based on the value of beta, we can classify the FIR filter into symmetric FIR filter and anti-symmetric FIR filter. If beta equal to 0, it represents a symmetric filter. If beta is equal to pi by 2, it represents anti-symmetric filter. Okay, here we said that alpha is the proportionality constant that shows the slope of the graph, that represent the slope of the graph. We can move on to the classification of, next we can move on to classification of FIR filter based on the value of beta and capital N. N is the length of the filter or number of filter coefficient. And beta have two values. If it is 0, we can say that anti-symmetric filter. If beta is equal to pi by 2, we can say that anti-symmetric filter. So based on beta and n, we can categorize the FIR filter into 4. And the first category is that the symmetric FIR filter with n is odd. The number of filter coefficient is odd. That is termed as type 1 filter. And next one is the symmetric FIR filter with n is even, and it is termed as type 2 filter. These are comes under the category of symmetric filter. So here beta is equal to 0. Then next the third category is anti-symmetric FIR filter with n is odd, and it is termed as type 3 filter. And next category and last category is the anti-symmetric FIR filter with n is even, and that is the type 4 filter. These comes under the category of anti-symmetric filter. So both of this case beta will be pi by 2. We can explain in detail. First we explain about type 1 filter. I already said that in the case of type 1 filter, n is odd and it is a symmetric filter. N is odd. That means the number of filter coefficient is odd. We check with an example. Here h of n, we consider h of n is 1, 2, 3, 2, 1. And the number of filter coefficient, and it is 5. It is odd. And it is symmetric filter, that means beta is equal to 0. Why we call it as a symmetric filter? When we plot the filter coefficient or impulse response, when we plot the impulse response h of n, what you can see in this figure? In this plot, it is clear that it is symmetric with respect to the index value 2. It is symmetric. The plot is symmetric, or impulse response is symmetric with respect to index value 2. So in general, we can say that the center of symmetry is denoted as alpha, that is equal to n minus 1 by 2. You can check that. N is 5. So 5 minus 1 divided by 2, you will get alpha is equal to 2. So here center of symmetry is denoted as alpha. With respect to alpha, the impulse response is symmetric. Okay, you can check, you can see here in this plot, it is clear that with respect to 2, here center of symmetry is alpha equal to 2. With respect to the index value 2, the impulse response is symmetric. And we can say that h of n is equal to h of capital N minus 1 minus small n. You can check this mathematical expression here. Here it is clear that we can say, if we then capital N is 5, we know that capital N is 5. Capital N is 5. So we can say that h of n equal to h of n is equal to h of 4 minus n. H of 4 minus n. H of n is equal to h of 4 minus n. We can put the values. N is equal to 0, h of 0 is equal to h of 4, h of 1 is equal to h of 3, and h of 2 is equal to h of 2. Okay, you can check it in the plot. Okay, h of 0 and h of 4 are same, and h of 1 and h of 3 are same. You can check it in the plot. Okay, it is clear that h of 0 value is 1 and h of 4 the value is 1. They are same. The h of 1 its value is 2 and h of 3 its value is 2. They are same. Okay, so this expression will be satisfied. Okay, in the case of type 1 filter, we can say that the center of symmetry, the expression for center of symmetry is alpha is n minus 1 by 2. With respect to here, in this case, the number of element will be 5. So with respect to 2, the impulse response is symmetric. And it is satisfied this expression also. This is the type 1 filter. Okay, then next we move on to type 2 filter. What is the difference with respect to type 1 filter? Only the difference is that n will be even. N will be even value. So we consider an even coefficient. Here also, it is clear that this filter impulse response is symmetric and the center of symmetry can be computed by the same expression n minus 1 by 2. Put the value n is equal to 4, you will get 1.5. With respect to 1.5 alpha, with respect to 1.5, the impulse response is symmetric. So you can, this expression is satisfied here also. You can check it. This expression also satisfied here. This is the type 2 filter. Then we can move on to type 3. What is the type 3? It is anti-symmetric filter. It is anti-symmetric with n is odd. That means filter coefficient is odd and it is anti-symmetric. So you can check the filter response, sorry, impulse response, that is h of n is equal to 1, 2, 0, minus 2, minus 1. If we plot the impulse response, it is clear that with respect to alpha, here alpha, substitute the value of n is equal to 5, so you will get 2. Okay, with respect to alpha, this plot, that is impulse response is anti-symmetric. With respect to 2, the impulse response is anti-symmetric. And one more thing, here at the center of symmetry, the impulse response value is 0. The value of h of n at the center of symmetry is 0. Here center of symmetry is 2, so h of 2 equal to 0. Or in general, we can say that h of alpha is equal to 0. Alpha is the center of symmetry. At the center of symmetry, the value will be 0. Okay, here the expression satisfied for the impulse response is that h of n is equal to minus of h of n minus 1 minus n. Here there is an extra minus sign is added. What is the reason? Here the magnitude are anti-symmetric. Here we can check it, h of 0, value of h of 0 equal to minus of h of 3. And value of h of 1, that is 2, equal to minus of h of 4. Sorry, there is a change. Value of h of 0 is minus of h of 4. And value of h of 1, that is minus of h of 3. Here 1, here minus 1. And here plus 2, and here minus 2. Substitute the value of small n, you will get this expression. Here with respect to alpha is 2 here. With respect to alpha, the impulse response is anti-symmetric. Then move on to the last category, that is a type 4 filter. Here the difference is that the number of filter must be even. Filter coefficient must be even. Here also with respect to alpha, you can check that alpha is equal to n minus 1 by 2. Here n is 6. So with respect to 2.5, the impulse response is anti-symmetric. Here also it satisfies the expression h of n is equal to minus of h of n minus 1 minus n. This minus represent the filter is anti-symmetric. Okay, that means h of 0 equal to 1 equal to minus of h of 5 and h of 1 equal to minus of h of 4 and h of 2 is equal to minus of h of 3. You can substitute the value of n, you will get this all these expressions. These all are okay. Thank you.